Hey guys, welcome to question FM323 of the Further Maths Fortify study guide. This question reads, a typical goal face and ball in Rocket League are presented below. The radius of the ball is 1 meter. The length and height of the goals are 10 meters and 5 meters respectively. The diagrams below are not to scale, and then we're given two diagrams that look similar to these ones here. If the radius of the top corners of the goal face is the same as the radius of the ball, how many times larger is the area of the goal face compared to the cross-sectional area of the ball? So the calculation that we're going to use to solve this question is going to be to put the area of the goals over the area of the ball. That will leave us with how many times larger the goals is than the ball. So, taking on the slightly easier one first, if we're trying to find the area, of course this is the cross-sectional area of the ball. So the cross-sectional area of the ball, we're going to use pi r squared because that cross-sectional area is a circle. Substituting 1 in for r, we get pi times 1 squared, which of course is just going to be pi meters squared. Tackling the area of the goals is a little harder, but definitely not ridiculously hard. All we need to do is break down these areas a little bit. So the first thing is going to be these corners. This question gets a lot easier once we take out these corners here. Now these corners, we know that this curve is the same as the curve of the ball. So this corner here would make up 1/4 of the cross-sectional area of this ball. So these lengths here are 1 meter and 1 meter, which means we could break it up like this. So we've got a rectangle here that is going to be 4 by 10. So taking off 1 meter at the top there, starting 4 meters by 10 meters to make that big rectangle. To get the smaller rectangle, this is going to be 8 meters because we've got 1 meter and 1 meter. So this one is going to be 1 by 8 to get the area of that smaller rectangle. Now we also found that the cross-sectional area of the ball was going to be pi meters squared. So seeing as these two corners would make up half the area of the ball, we're also going to add pi on 2. Now that we have this set up here, we can go back to our original formula. So we're going to have 4 by 10 plus 1 by 8 plus pi on 2 all over pi. And this, putting into calculator to one decimal place, is going to round to 15.8, which is option C. If you guys have any questions about this question, please drop them in the comments below. Otherwise, I will see you in the next video.